Enterprise marketing teams are rushing to integrate artificial intelligence into their daily operations. But behind the enthusiasm for new models, marketing leaders are finding that their actual customer data infrastructure cannot support them. While 75% of marketing leaders report adopting AI, only 31% can actually unify their customer data. That massive 44-point gap is exactly why high-profile AI pilots fail. They operate on fragmented, disconnected systems. A predictive model cannot function without a unified foundation. To make AI work, the surrounding operational architecture requires far more attention than the model itself. This diagram illustrates the 7-layer architecture required for accurate targeting and legal compliance. It begins at the bottom with 2 foundational platforms. Layer 1 is the raw data layer. This is where you collect customer records, including transactions, web events, and explicit consent logs. Every piece of information entering this layer must carry a permanent record of its origin, the date it was collected, and the specific channels the customer authorized for communication. Those raw inputs flow upward into Layer 2, identity resolution. Here, fragmented identifiers like email addresses and device IDs are reconciled into a single, reliable customer profile. Organizations often make the mistake of forcing a match when confidence is low. Doing so risks merging 2 distinct individuals, which can expose one customer's private behavior to another. Without absolute certainty in data provenance and identity resolution, downstream personalization ceases to be a marketing asset and becomes a legal liability. Once identities are unified, the data moves to Layer 3. This is where historical events are translated into features and labels, the specific numerical inputs a machine learning model can actually process. The most fatal error at this stage is target leakage. This occurs when data from the future is accidentally included in the training set. This timeline illustrates how target leakage corrupts a model. If you calculate customer features using information from the future, it bleeds backward into the historical training environment. The model learns to cheat, resulting in an artificially high accuracy score. But because it relies on future data it won't have in the real world, the model immediately collapses in live production. To prevent algorithms from learning false lessons, data engineers must strictly enforce point-in-time calculation rules for every feature they build. With the data prepared, we reach a strict operational mandate. Probabilistic AI tasks must never be merged with deterministic business rules. This flowchart shows Layer 4. Predictive AI assigns an 85% propensity score, while generative AI drafts a personalized email. Both converge at Layer 5, the decision and policy layer. This rigid enforcement zone blocks deployment, despite perfect scores and flawless copy, if the customer has legally opted out. A language model excels at drafting copy, but it lacks deterministic logic. It cannot independently evaluate whether a customer is legally contactable. Isolating business rules into a dedicated policy layer ensures that the automated marketing program remains completely legally defensible and auditable. Approved scores and treatments finally move to Layer 6, the activation layer, where they are executed by CRMs or direct email platforms. This execution depends entirely on logistics. A sophisticated model fails if the customer identifiers do not map precisely to the destination platform in time for the campaign. Federal enforcement agencies closely monitor this automated activation. They treat AI bias and discrimination exactly like human-driven violations. European jurisdictions maintain even tighter restrictions, often giving consumers the explicit legal right to opt out of solely automated decision-making. Applying the label AI to a tool does not grant an exemption from consumer protection laws. Without dedicated governance at the policy and activation layers, an automated system simply scales the speed of non-compliance. This diagram introduces the final component, Layer 7. Measurement routes exposure and cost data back to the foundational layer, forming a complete closed-loop circuit. If campaign outcomes fail to flow back to the analytical environment, the system remains static and incapable of self-correction. Evaluating this loop requires 2 distinct checks. Model validation ensures the mathematical stability of the predictions, while campaign validation proves those predictions actually caused a profitable outcome. Relying strictly on model accuracy leads to the incrementality trap. A model might successfully identify customers who are highly likely to buy, but generate zero net revenue because those specific individuals were going to purchase regardless of the marketing intervention. This visualization shows the gold standard, a randomized control holdout. While the AI targets the treatment cluster and drives conversions, the isolated control cluster reveals how many conversions happen organically. By subtracting the control group's organic conversions, you isolate the only metric that matters, true incremental lift. Optimizing an algorithm exclusively for click-through rates or raw conversion probability is flawed. A successful system must strictly measure the net new revenue generated by its actions. The specific predictive and generative models that are available to marketing teams today will rapidly become commoditized and universally accessible. Advanced algorithms offer no durable competitive advantage if they run on a disorganized data layer. Modern database marketing relies on three strict pillars: perfect permission tracking, separation of prediction from policy, and relentless incremental measurement. Mastering this 7-layer architecture is what determines whether artificial intelligence functions as an engine for measurable business growth or just a faster way to make automated mistakes.